All right. Welcome to Graph Interpreters in Rust. I didn't record last session, so I think I'm just going to start with a recap of what we ended up doing. So we implemented some more the of chapter 10 about how to uh, declare and call functions. Um, and we were sort of we ran into a few sort of gnarly details of how to implement it. Um, So let me go through sort of the diff here. The big change is just we figured out what to do when you hit an expression, a call expression, a function call expression. There's some certain things we're leaving to do for later, but we can, at the very least, all this indenting is just making sure that the function is declared properly. And if it is, then we can do the actual function call. So the steps in a function call are you have to evaluate all the arguments that were passed into that call, make a brand new environment, which is outside of the current stack for the function call. Um, and then the initial state of the environment inside the function's scope is that the parameters are defined to be like the values of the arguments. So each parameter name is defined as a variable in that environment and given the value of the argument. And then you go and interpret the body of the function. And somehow you have to get the return value of the function out of that. What we decided to do is uh, embed it into the function's environment. So it doesn't get returned out of the interpret statement call here. It gets packed into the environment with a special key. So that means that this is sort of a reserved variable name, except I think the user can't actually make a variable with this name because it has spaces in it. So we don't have to worry about that. But yeah, this is a special constant magic word key, which is we are using to encode the return value in the resulting scope. And in order to retrieve it later. So we discovered sort of a problem, which is that the let's see. Right, we did some stuff to play nice with Rust's lifetime or borrow checker. And then when you return, what you do is uh, you evaluate the expression that's supposed to be returned. So like if it says return A plus B, then you better have A and B in your environment, and you better be able to add them. So you do that, you get a concrete value you're supposed to return, and then you pack it into the state with that special key. And then something we still need to handle is the fact that you're stopping the function execution there because you hit a return statement. Um, so right now it'll just keep going past the return, and I guess whichever return statement was hit last will be the one that you end up actually returning. So it's not correct yet. We're going to be working on making it correct. And I guess the other problem that we ran into is that the inside the body of the function, you can actually call further down, you can make further scopes. So if your function looks like this, forgot sort of the full syntax, but it doesn't matter. So A, B, and return A plus B. this return statement is at the top level scope of the function, which means that the return value will be populated in the right scope. But in order to break that, all you need to do is this. Now there's an inner scope. The return value gets populated in that scope. That scope gets popped, and then now the return value is not in the right place. So there are a few changes we need to make for this to work, which I will try to do today. So the first one is make return value always written into the parent scope of the function. Not the parent, sorry, into the highest level scope within the function's env stack, right? So when we create the execution sort of context for the function, we make a new environment stack, which is only one environment tall. And that means that this is the thing which should have the result at the end. Because everything else can get popped. So that's fairly easy. I just need to make some kind of special way for the environment define to happen at parent scope, which only needs to be run here. And then two, make hitting a return statement pop. All right, I guess actually return execution to the caller. So in Java, in the book's Java implementation, they did this by throwing an exception, and then using Java's like it would keep bubbling up until they catch it, and they catch it at the parent at the caller's scope. So they basically are just taking advantage of throwing and catching exceptions the way that works in Java. We shouldn't do that. We want to do something more rusty and explicit. I don't really know what that is yet, but we'll figure it out. Okay, so what did we do? Apparently we didn't write any new tests. We just wrote some partially working function code. So let's just keep going on that. All right. So I'll go down to this, where we call function. And so inside this interpret statement, or really actually when we get to a return statement here, we want to put in highest level of state. And we're putting the return value. Not lowest level as define would usually do. Let me see if I can reach into the data directly. If I can't, then I guess I'll just define a new method on the env stack class here, or struct. Okay, so state dot 0 dot first. So this is giving us the first thing in the first thing in the stack, but Yeah, this feels weird. I'm just gonna make a method for it. So is env stack in here? Where is it? Yeah. All right. It will be almost like this, except called define global. And instead of self.current mute, it will be self.0.first mute. Okay. And what's wrong with that? Probably wants me to unwrap. Here, I'll just wrap this. What I'm really doing is sort of the same thing as this, except top level. First mute. There we go. Okay, and then it's just self.global scope. There we go. All right, and then down here we're saying state dot define global this return value. Okay. So that's that. The second thing I don't know how to do yet. So let's just think about it. Or if you guys have any suggestions.
So the goal of that second thing is, so once you've put the return value in the highest scope to actually end that function's execution.
Mm-hmm. Yep.
Okay.
So I want to I want to not print hello somehow. And also I want to not print hello however deep we are. Right? Because I can't just end the scope, I have to actually exit to all of the all the way back up to the caller.
Is that going to require cleanup of any of the inner scope statements or states for the environment?
Well, I think we can just dump all of it because we're done
Okay.
executing the function, and we made a new env stack just for the function, right?
Yeah.
So that entire thing can be garbaged at that point. It's just that we need to know where to come back to. So let's think about it. So what we're doing is a recursive descent through the function. So we're going to recursively descend, like, okay, our entry point into this entire thing is interpret statement. We're calling interpret statement on the function body. Then at some point during the execution of interpret statement, which goes out and calls other things recursively because we're doing recursive descent, we will hit a return statement. The return statement needs to like it needs to stop the execution of everything above it inside this entire recursive call. So like it's, to be fair, it's a pretty good place to use an exception. I'm just trying to think like, so what we might need to do is just have like the standard thing to do in Rust instead of exceptions is to use like results or options or something. but that would mean that we'd have to be able to bubble up the fact that we've returned through every possible like function we could be executing, right? So, yeah.
So would that be using like the error condition on the, or the, like, what is it, option has, the two different, for the results, so, for the rate values.
I think it would mean this. So, right, so, from interpret statement, let me go look at interpret statement to see what we can recursively call. We can call eval expert, we can call interpret, and we can call interpret statement again. And that seems to be it. So all of these things need to be able to understand early exit conditions. So that means that they need to return a result. So this is going to be really red, but eval expert has to return a result of a value, and then interpret, wherever that is, needs to return a result. And the only point of this is, let's see. It just feels like a lot of noise in the code for doing this. Right, because so basically like all of these have to return like okay.
But then
So
would one of them actually return an error, or would it
yeah,
stop the recursive descent?
right. This would return an error.
Okay. It's
Except it's not really an error, it's just like the other side of the return or the other side of the result. It's a yeah. Okay. So let me think. So if I do that, what does the code look like? So this we're gonna do a lot of question marks everywhere, right? I think. Hmm. So, okay. If I do this though, what is it? So the reason that the question marks are doing what we want is because that means if you encounter an error, you bubble up the error. So we're basically just emulating what Java would do with stack traces or with exception handling, but here. So I'm going to try that for now because I know that that's basically the behavior we want. I don't, but like, okay, I don't know where question mark can be put, honestly. I'm just winging it. So I'm going to say that anytime that we do an interpret statement, anytime we do recursive descent, it has to be this. Um,
so it's going to unwrap it otherwise.
yeah, okay. Let me just make a basic Rust example so I understand more what I'm doing. All right, there's the thing I'm supposed to use. Okay, so all right, let's just do an explicit. Yep, okay. That's not it. It doesn't return a result, but here's a fallible operation. And I'll say that it takes 32 if x mod 2 equals 0. It is an okay. Otherwise, it is an error.
So you're basically relying on with the question mark to just keep returning the error up the stack, but otherwise unwrap the result type and process that.
Yes. Right. An error is what here?
I think maybe you don't want standard IO error, but just standard error, right?
Is that here?
Yeah, because it's looking
Okay.
for
Standard. Okay, so error. Maybe I want this. Okay. I kind of thought there was a thing where it would like default to some sort of error type.
well, standard IO does have error results in errors, but that's not what you're trying to use here. I think you're just trying to use a regular
Yeah.
standard result or whatever.
Yeah. Okay. I think that's what I was thinking. But yeah, what I meant is this, right? That yeah, the version of the result where it like does some standard thing for the first parameter. So what's this one? No. Still wants me to supply an error type. Okay,
But you just want to use string or something, right?
sure. That works. Maybe. All right. Okay. So this should be the same result. Let's see. Type result. Whatever. So this. Okay. All right. So what's wrong with this? So interesting. So it's returning the inside. So if I do this, then it's the same type.
Does it only return the inside for if it's successful?
Yeah. See what I thought? Okay. What I thought it was.
Oh,
Okay. So this might make it easier. Okay. So this termination is not satisfied. Hmm.
it's
Why was it okay with that then? I feel like this type and a int shouldn't be any different because they can both, as far
Yeah.
as memory is concerned, because they're both on the stack. Okay.
So when you had that, because what was the error again when you had that as I-32? It was that it was saying that it was incompatible. So even though
Yeah, let's
when you
let's
had
figure it out.
okay as a number, okay, and then so it's saying that the trait boundary.
So I-32 needs to implement termination, which is some sort of trait. Let's figure out what that is. Um,
Oh, is that's for, it looks like for main specifically, if you're returning, since there's that return, the fallible thing that's going to then return from main,
mhm.
but it looks like there's you normally have to send an exit code.
Yeah.
So it needs to be, I guess,
So termination is like convertible into an exit code.
yeah, looks like there's, yeah, let's see. Hmm. Um,
Um,
Termination trait is defined in the standard process module, it looks like. And that
yeah. Okay.
you would need to see.
So somehow unit has implements termination and string implements termination.
Yeah, if it's just the unit, it says like main returns okay with the unit, then it exits with 0.
Yeah.
So I guess that's why it worked with
Okay. So anyway, the thing we were trying to figure out is what exactly does a question mark do in terms of types. So if I say this, I think what that's doing is it's turning it into unit because it's unwrapping it, except it bubbles up the error. So if I say let x equals that, okay, x, I think that's fine. Because
oh
if it's
yeah.
because that means, so if this failed and returned an error, then that'll get returned and it's a result. If it was an okay from the inner function, then the inner thing gets assigned to x. So x is a unit. And then I'm re-wrapping that back in a result.
Yeah.
So that's sort of how it's meant to be used.
Okay.
So let's see if we can think what it would do for stuff like this. So I think I'm a little overwhelmed by just the amount of red that's here. But once we know like sort of what we're supposed to do in general, I think
So
it won't be bad.
So the idea is to use the error side to be the part that when you're returning from an inner scope, that you can then, did you have to you catch that at the very top? Is that
Mm-hmm.
sort of, okay.
Okay, so I think basically what we need to do. So this interpret function, for example, didn't return anything before. And now we want it to return a result early if one of these things like hit a return statement. But otherwise continue to the end just like we did before, and then return an okay with nothing in it. So okay. So basically, yeah, this, can I put a question mark there? Question mark. Yeah. That's the idea. So now, anytime if as we execute over this, blah 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 blah, we hit an eval expr, we question mark it. If it ended up hitting a return value, then that goes right back up. Otherwise, we continue with our current flow. And then if we get to the end without hitting return value, we just return okay. And basically, we don't need to use this. It's just to make it always return a result. So let's see about that for the other ones.
So going back to the mini example, would it be easier to think of that if we got rid of the result from main and handled everything in main as if, because that's us, right? Don't we want to?
Not really, because the thing about it is, we know that at this level, it's going to resolve the error. We want it to hit a return value and then go back up the stack and then get back to here, which is the caller execution. I guess, yeah, the execution of the caller. But it could hit that at any point, at any depth in the function, right? So we want it to hit this and then stop executing the rest of the function, which means it has to get out of potentially arbitrarily many layers of recursive calling. So it's sort of, so, you know, in main, I guess you could, it depends whether you're thinking of main as the caller or just one of the many layers of recursive execution, right? Does that sort of make sense, or was that not really what you're talking about?
Yeah, I guess I was thinking of main as sort of the top level, and if we made it all the way up there, then we want to handle it. We don't want to just hand it off to the operating system or whatever.
All right. So if we make main not return anything, then question mark can't be used anymore, because that's just how it works. The question mark is an abbreviation for like an early return of a result. So it's
so we would need another wrapper.
Right. At that point, we could just match on fallible thing, and it's either going to be an okay or an err.
Yeah. Right.
And that's literally all that's literally what question mark is doing. It's shorthand for that big long match statement. Well, I propose just writing the big long match statement, and then at the top level, that's
what we have to do at the top level. Yes. My question is, how do we have the rest of the code look fine in the recursive descent that we're doing? Like, so at this level, we are, I guess, we don't actually care about whether it's an okay or an error. We expect it to be an error, I guess.
I guess if you want to try the question mark thing, we could just do another level below infallible or whatever, right?
Yeah, right. So right. Let's name these appropriately. So we'll have a eval outer, and then we'll say that it will be eval inner x question mark. All right. And then at this level, we want to call eval outer. Like this is the caller. So.
But at that level, we want to match on eval outer, and we want to know if it succeeded or not.
Yeah, and here we don't need to return anything. We actually don't even need to know if it succeeded or not. Like we don't need the match.
Oh, okay, right. Yeah.
Because the only point of any of this is just to stop the execution at the point where it does a return value.
Right. If the return value is unit, we haven't really learned anything, I guess. So we don't care.
Yeah. So I think that's right. I'm gonna try following through with that for the rest of these and see if it works like we think. All right. So this one is a little weird. I kind of forgot if oh, interesting. Interesting. So this one, yeah, so here we actually have to do a bunch of stuff because it returns values in a bunch of different places. Okay. Okay. I could just set a, instead of just returning here, I could set a thing. Yeah, I think that seems right. At this level, we know we're not hitting a return statement, right? Hmm.
But if you,
No, this is a giant match, so we don't. All right, I'll just do the tedious thing. All right. Okay, eval expert is just another results, so all good. Question mark. Okay. All right. Pair of numbers. All right, so we had a helper function here. I'm just gonna, I think this will be fine if we just put some question marks beforehand. Yeah, question mark. What's, yeah, question mark.
so those you don't need to return okay for the binary operator.
I do. I'm just doing this first.
Okay.
Okay. Okay, this is a result. Oh, I didn't put it on all of them. Okay. Mm. All right, so what's wrong with this? Question mark. Okay. All right. This means we need about yeah, there we go. I don't know if the question mark works at that level because it's inside a map closure. Okay. So I can't do a question mark there. This will be a bunch of results. What's that supposed to do? I'm guessing that we forbid return statements inside there, but who knows? So like that would mean that would mean this. sum return 5 return a plus b var a equals sum return a plus b. Yeah, that doesn't seem possible because this is a statement, not an expression, right? Okay.
Oh, and since you can't do the question mark inside a closure.
Right. So the question is, what do we even want to do here? So like,
You
is
do
it
your error
even
handling in the map statement, like set up like is it
so if we did question mark, the behavior would be, or if we brought it out of a map and just put it in a for loop, then the behavior would be that it just returns the first one that threw an error. But
But you're saying that wouldn't make sense because you would normally, if you have a statement, like it wouldn't make sense to have a return statement inside for example, one of the arguments.
I think so. And I think these have to be expressions according to the parser. I don't think it would parse.
No.
But we have to handle it. So I can just unwrap.
Can you collect the results and then do something afterwards?
Yeah. But that would sort of defeat the purpose of the error state, meaning early return, because we're actually evaluating all of them, not including the ones after we returned.
Yeah.
And I guess there wouldn't be a case that you would need to evaluate multiple things in that situation, that if you had a return and other stuff, you would need to evaluate that too. I guess you can argue as soon as you hit a return statement in that evaluation, then you would want to stop. Oh, yeah, there, okay. Now, if you have one argument, I guess, would it be valid there?
I think maybe this is the problem with this is that we're trying to use errors still, just like Java is, because we want the same behavior that Java has, except we also haven't really handled errors ourselves. We just panic. Right? We just decided to solve errors later. So it's possible that we would have had to do this anyway whenever we decided to handle errors in a better way. So I will just have to think about it.
Well, does that mean there's kind of almost two classes of errors? There's errors that are for the recursive descent, just saying, and then there's actual real program errors, part compiler errors.
Yeah. So we set this up a while ago, but it's possible what we want is locks. We want like locks evaluator, enum locks evaluator error, which is either a locks runtime error or a return, early return. Right. So we fire an early return when we hit a return statement. We fire a locks runtime error when we hit an actual evaluation error. both of them get bubbled up, but then they get handled differently. So this contains a Box-Stein error like we were using before. This contains nothing. It can even contain the return value, actually. We can signal it inside the error instead of putting it onto the stack like we do. I might do that. Yeah, I'll put that here. Maybe use this for errors instead of panic. Yep. Okay. I'm sure it doesn't like that somehow. Yeah, don't use semicolon. All right. So what are we still missing? So what we want is to return the return value from the function call means this. Yeah. Okay. And then finally that. All right. We're not red anymore. Let's see about if the test worked or if I broke everything. I broke everything. So what are you trying to, what's the problem? So probably just yeah, there we go. That fixes that or not? Okay. Um, really? You can't use eq?
Hmm.
Huh. Okay. Well, this is sort of what we have to do, except I need to figure out how to actually compare them. Maybe unwrap. Yeah.
Oh, because the result is unwrapped. Or no, you don't have the question mark, so
Yeah, it's like this. Yeah, I don't have the question mark because this, and I can't because this doesn't return a result. Okay. Very good. We don't fail any tests. See, sometimes rest is cool because you can just do that. All right, so okay. So I don't know if we actually did this, but let's find out. So the remaining thing to do is when we have a return statement, we need to actually throw an error. Yes, so return error. This is a Box-Stein error. Do we actually return this anywhere else? I don't think so. Let's see. How does this work? I need to specify some sort of error in here.
Doesn't string usually work for everything?
The string implement like this.
No, just that string implements error, I guess. Yeah, like that.
All right.
No, I guess not.
All right. There we go. Why does this work? So it's using some from traits, which won't be explicitly implicitly called. Okay. Maybe I don't need maybe I can also do it on an answer. Da, 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 da. Remove these generics. But I added the generic so that it would work. I do that. Can do that. Crazy. All right. So early return. There we go. So let's see what that does. So how do I actually test that it does the early return correctly? I need to write a test for it.
So would you do that program that you showed with a return statement, like in the if true?
Yeah. So I can do this. This already works. But yeah. All right. So let's do I don't know. Let's see. How do I do that? I guess, oh, I know what to do. We can do a plus a times b. So it should still be 11. It should not be 30. Awesome. Okay. I think that does it. Let's make sure that it happens even if we're nested. Yep.
I don't, oh, sorry, I missed where the value was being shown of 11. Oh, there, down. Okay, so when you did
Yeah.
the assert down there, right?
Just to make sure. Yep,
Okay.
cool. I think we did it. Not positive because it felt too easy. But yeah, okay. There we go. I think we did chapter 10. I guess next it's the end of the scheduled time. So next time we'll look and see if we missed anything from chapter 10. And then if we didn't, we'll keep reading.
Sounds great.
Thanks for your help, guys. That was fun.
Yeah, thanks. Yeah, it definitely was fun. Helps a lot with my rust. Especially hearing both of you.
All right.
All right.
See you later.
Okay, bye.